What is the partition coefficient? The partition coefficient is a ratio of a solute between two miscible liquids. So let's say I have two miscible liquids, okay? I have oil and water, and I dissolve caffeine, okay? Or in a solute. The partition coefficient is the ratio of the concentrations of the caffeine in oil divided by the caffeine in water. Now, the simplest way how to write this is solute water or aqueous with solute in ether. And I love doing an ice table anyway. So in the beginning, you have 4 grams of solute in water. And this becomes 0 for the ether. Then you have minus x and x because some of it will dissolve in the different solvent. Okay? So at this point, you have, okay, at this point, you have what we call two immiscible layers, both with some of the solute. Kd is equal to concentration of solute in ether over solute in water. When you work it out, this will give you 3.8 equals x over 100 divided by 4 minus x over 100. To simplify things, I just divide by the volume. Okay? To simplify things, I just divide by the volume. At least, that's how I work it out here. Then, you can simply remove those, and when you work it out, x equals 3.17 grams. Okay? So, if you were to then put in the numbers, back in the numbers, this becomes 0.83, this becomes 3.17, and you should know that 3.17 divided by 0.83 when you work it out is 3.8. Okay? Remember, the volumes are the same. The second part of the equation was the solvent is added as two consecutive 50 centimeters cubed volumes. Now, this, a lot of students start to panic. But, the reality, the only thing that will change, literally, the only thing that will change in the beginning for the first bit, okay, is that initially, you do not have 100 centimeters cubed of ether, but rather you have 50 centimeters cubed of ether. So that becomes 50. Some students at this point decide it's easier for me to work it out mathematically and have it like this. Okay, where that becomes 2, so then 3.8 equals 2x over 4 minus x, and they work it out, continue it from here. Honestly, for me, it makes no difference. Okay, for me, it makes no difference. What you should realize is that here there will be x for this one. X equals 2.62 grams. And you might tell me 2.62 is less than the 3.17 we had before. But that's just the first one. Once you do all this, then you do not have 4 grams for the second extraction, but rather you have 1.38 grams on its own. Okay? Then you have 1.38 grams on its own. And because you have the 1.38 grams on its own, what you do is you can simply work it out. Okay, so then, and I'm gonna change the color to purple so it makes a difference. The 4 becomes 1.38 everywhere, which is, again, it's the only thing that we're changing, right? But of course, you have to do it as two separate ones. So, x minus 2. Then, I also love, apologies for closing the video, I also love to actually make sure that when I am working these questions, instead of using x and x, okay, I normally use x and y. I find it a little bit simpler, okay, but that's me, that's Patrick Camilleri, okay. For you, maybe you want to use x's because you've always used x's. So I'm also going to change the x into a y. Again, because I find this simpler. Okay? But again, this is a preference of mine. This is not actually something that will make a difference for you. And now, when you work it out, y equals 0.9 grams. Again, you see that now x and y is going to be 3.52, which will be a little bit more than what you had initially. This was known as a double extraction. This is what we use for washing machines. Small amount of volumes in order to actually extract as much as possible. Hope you enjoyed it. Till the next one.